Sorry, it's interfering. Right, good afternoon, grade 9. I'm greeting you guys. Right, sorry for that sound. It's interference because I'm trying to project it so that you can see it, right? So sorry for that inconvenience. However, let me then just continue. Right. May you all take out all your NS books? then you just open where your activity, that's the assignment number 15 is. Now, my major issue here is I just want to have a discussion with you. Let me Hello, sorry. I was just trying to connect my class so that I won't have a lot of interference. Yeah, but I think it's now fine now. Right. What I've just noted is from the previous tests that you wrote, I've noted that there are so many challenges with regards to the periodic table, especially on drawing the diagram. That's the atomic structure, right? Then again, there was a problem on balancing a chemical equation. So in my topic, I just highlighted those items so that we can go over those items. And we are revising as well as preparing for the final exam, right? So there are so many challenges that are on drawing the atomic structure. Now, we are going to deal with that as we will be answering the questions on assignment number 15. Right. Then I'm going to use that assignment number 15. Now, if you check the first question, the question one, we are given a symbol, right? Then from that symbol, it is a symbol that is in the periodic table, right? So whenever you are looking at an element in a periodic table, you must know all the information about an element, or you must know the information that is on each and every element that you are given. So in that case, we are given a symbol that has got what? 12 at the top. Then there's a sign, omega, that has been used, right? Then there is 24 at the bottom. So you must know the meaning of each and every sign or each and every number that is on an element in a periodic table, right? So in most cases, we first of all start by writing the atomic number. The atomic number is always on the top. Then the other number at the bottom, it is the mass number. However, at times you may find out then that the numbers will be in the opposite position. When I say opposite here, it's like the atomic number is at the top. You will find it at the bottom. Then the mass number is at the bottom, but you will see it at the top, right? They will have been what? Swapped. So you need to make sure that, you need to remember that the atomic number is always smaller than the atomic mass. I repeat again, always remember that the atomic number is always smaller than the atomic mass. So in this case, the numbers or the two numbers are in the correct position. We have the atomic number at the top and the atomic mass at the bottom. But the symbol that has been used there, that's not the correct symbol, right? So whenever you are looking at the element, you have to quickly go on to the periodic table and check and verify the information before you start what? Answering questions. So it's very, very important. Now, so if you check on that one, it's 1224. Then you must then quickly go onto your periodic table and check the element there. What element is it from the periodic what? Table. The smaller number is 12 and the bigger one is 24. So we must know what element it is. Now, if you check on the periodic table there, right? If you still remember, we say the periodic table has got what? Groups and periods. Groups and periods. When you look at the top here, there are those numbers, number 1 up to number 18. Those are groups. In other words, our columns are our groups. Then on the left-hand side of the periodic table, we have rows. So those rows, what the special term that is given to each and every row there? I'm asking you now, guys. What is the specific name that is given to the rows in a periodic table? We said columns are groups. What about the rows? Yes, that's correct. The rows are now periods, right? Now, if you check on the periodic table there, in which period is it? The symbol that we were given, which row do we find 12, 24? Quickly, please, quickly, please. Remember, the elements are arranged in order. So which row number? Is it row number 1, number 2, number 3, number 4, number 5? It's row number 3, which means it is in period number 3. If you say it is in period what? 3, it means it's in row number 3, right? Now, if you check, the first one is capital letter H there. That's the first row. The second row, we've got a capital letter L and I, small letter I, right? Then the third one, there is capital letter N and a small letter A. That's the third row. That's where we've got 12, 24. I think we are seeing whatever I'm talking about right now, right? So it's period 1, period 2, period 3. So the element that we are given, that element that has got atomic number 12 and mass number 24 is in period number 3. Now, what is the group number? It's group number 2, which means it is in column number 2. That one is fine, right? Now, so when we are looking at groups, boys and girls, we are just looking at the number of elements that are in the last electronic shell of an atom. Am I clear there? The group tells us the number of electrons that are in the last electronic shell of an atom. Please take note of that, right? Now, which means according to that element 1224, how many electrons are in the last shell? There are 2. Why are you saying it's 2? Why are you saying there are 2 electrons in the last shell? Because it is in group what? 2. So the number of electrons in the last electronic or electron shell is 2 because it is in group 2. I think that one is clear, right? Then how many rings are there? Or how many shells are formed by orbiting electrons? How many are they? There are? Why are you saying there are 3? Right, because it is in period what? 3. It means there are 3 shells around the nucleus. So that one is done, right? Now, so we are saying our period tells us the number of shells around the nucleus. That's sorry, let me then admit this one. So if you are in this class, I think you can now switch off since it is working, we can see, right? Now, let me then continue. Now, so we are saying period tells us the number of electronic shells, that is the number of rings or electron rings around the nucleus, right? Then the group tells us the number of electrons in the last or in the outermost shell around the nucleus. I think that one is now clear, isn't it? Now, if you check on the extreme right, we have got some Roman numerals there, right? We have got 3, we have got 4, 5, 6, 7, and 8. I think you are all seeing that, right? Right? In the columns or in the groups. Now, what it means here is, say, for example, if you are looking at column number 13, that's group number 13. Under 13, there is what? There is 3, right? So that 3 simply means that all the elements under that 13 or group 13 have got 3 electrons in their last electronic shell. That's what it means. From which class? You are not hearing what I'm saying.
Yes, you can understand anything.
There is a difference between understanding and hearing.
You don't understand, you don't hear anything said.
Okay, I'll try to pronounce everything slowly.
What you say?
Right, grade 9's classes, I would like to think that you are hearing what I am saying, right? Forgive me if you are not hearing it clearly, but however, at the end of this session, I'll post it on Google Classroom. Right, so I was just talking about the Roman numerals under groups. So I was saying those Roman numerals are giving us the information on the number of electrons in the outermost shell, right? Now, so it means group number 13, it has got how many electrons in the outermost shell? It means there are 3. That's group number 13. So the number of electrons in the outermost shell is what? 3. Then if you check on group number 14, the number of electrons in the outermost shell, it's what? It's what? What is the Roman numeral there on group 14? It's 4, right? Then what about group number 17? How many electrons are in the outermost electronic shell? There are 7. So you must also be able to what? Read the Roman numerals. I think that one is clear, right? Now, so those numbers are providing us with the information with regards to the number of electrons in the outermost shell. So that one is covered, right? Now let us now go back to the questions, right? Now, before I go back to the question, let's check our element. We said it's 1224, isn't it? What's the symbol of the element represented by omega? What is the symbol in the periodic table? Katlego? Thank you. Be very, very careful when writing elements. They always start with a capital letter, right? It's always a capital letter. So it's M what? G. And what does MG means? This is just for the sake of interest. There. It means what? That's magnesium. Thank you so much. Now, let me now go back to the questions. Then we move on. Otherwise, I just want to quickly go on to the structure of an atom, right? Now, the first question there says, the chemical symbol for the element is represented by omega. Then 1.1, what is the atomic number of the element shown above? What is the atomic number? That's 12, thank you. Always remember that the atomic number is always smaller than atomic mass. Then what is the mass number of the above element? That's 24, thank you. Then 1.1.3, chemical symbol and name of the element represented by omega. What's the symbol? It's capital letter M and small letter what? G, which means it's Mg. We always start with the capital letter whenever we are talking about elements, especially if we are having more than one letter. But we do have some elements that have got one what? Letter. So it's always a capital letter, right? Then what's the name? We said it's magnesium, right? Then 1.1.4, what is the group number? It is in group number, is it? May you verify and check whether it is in group 2 or not, right? It is in group what? 2. Then 1.2, determine the number of electrons, protons, neutrons of the element shown above. Now, how many electrons are there? So the electrons are how many are they? We said it's what? There are 12 electrons. Why are you saying there are 12 electrons? Why are you saying there are 12 electrons? Luandle. Sorry, I didn't hear you. Did you hear what she said? She said what?
She said that the atomic number tells us how many electrons and protons we have.
Thank you. So the electronic number, right, tells us all that information, right? Tells us how many electrons are there and how many protons are there, right? So we are saying the electronic, the number of electrons is 12, right? Then how many protons? You've already answered that one, isn't it? So the number of protons is also what? 12. The number of electrons is equal to the number of protons, right? What charge is possessed by an electron? This is just for the sake of interest, huh? For interest's sake. What is the charge possessed by an electron? It's negative, right? What about proton? Proton is positive. Thank you. Then now, how do we find the number of neutrons? How do we find the number of neutrons? What about the rest? Right, how do we find the number of neutrons? So it's mass number minus atomic number. Right? So it's mass number minus atomic number. So in this case, this is now equals to, the mass number is equals to 24. Then we subtract electronic number, that's the atomic number, which is what? 12. Then we get what? What's our answer there? That's 12. So that's how we find the number of neutrons. Then what is the charge possessed by a neutron? It is neutral, right? It's not charged, right? Then now draw the diagram. That's where the problems are now, especially on the test. There were so many people who could not get it right? Now, so how do we draw the structure of an atom? Always remember, whenever you are drawing a diagram, you must always start by labeling it, naming it, right? So what is the diagram that we are supposed to be drawing here? It's atomic structure. Always start with what? The topic. Atomic structure of magnesium. That's the atomic structure. That's what we are going to draw, or that's what we have been asked to draw, right? So we are supposed to deal with its atomic structure. Then we must always make use of a pencil whenever we are drawing a diagram. So I'm just going to try and draw a diagram here. Let's hope I will manage to draw the diagram. Sorry for my diagram. My diagram might not be all that good. Okay, let me make use of this. Right, so how many rings are there? How many rings?
3.
Are you sure?
Yes.
Okay, fine. So I'm going to draw 3 rings there, right? Because it is in period 3, so we must make sure that we have what? 3 what? Rings. Which period is magnesium in? Is it in period 1, period 2, period 3? Period 3. Period provides the information about the number of shells, right? So it's what? 3. Then I'm going to draw again another one. But it's time consuming. I've already posted the diagram to you. Should we continue, or I just highlight some issues here? Let me then just highlight issues, right? Now, so we are saying it is in period 3, so you have to draw 3 rings, right? Then from there, you have to also what? Leave space for the nucleus. In the nucleus, that's where we have got what? Protons and neutrons. So if you check on question number 1.1.4, we have already numbered, or we have already calculated or found the number of electrons, the number of protons, and number of neutrons. So you must make sure that you draw those what protons and neutrons in the central part of the atom. I think we are clear there. Then after drawing those subatomic structures, label them. Remember, the electrons are always around the what? The nucleus, right? Those are the charges that are orbiting around the nucleus. The protons and neutrons are in the central part of an atom. They form the nucleus. I think that is clear, right? So there must always be heading. There must always be what? The diagram, then label it. So what we were looking at when marking the structure of an atom is there must be a correct diagram, or there must be a diagram. Then we were very strict on number of electrons on each and every what ring, or on each and every what shell. Now, the first innermost shell has got a maximum of how many electrons? It has got a maximum of 2 electrons, which means the innermost shell must have 2 electrons. Then the second shell, it has got a maximum of how many electrons? We are stuck now. Let me then go to the periodic table and highlight something there about the number of electrons. Now, please check on the right-hand side. Right-hand side, we have got helium there, right? That's where my highlighter is, or where my cursor pointer is, all right? Are you seeing that? That's helium. And you can see there that at the top, the atomic number is 2. And that's the last element in that row. So it means there are 2 electrons in the shell. In hydrogen, it's got only 1 shell because it's in period 1, right? Same applies to hydrogen on the far left-hand side. But hydrogen has got how many electrons? How many electrons are there in hydrogen? It's 1. So that shell has got 1 electron for hydrogen. But for helium, it has got what? 2. And it is the last element in the periodic table. Who said so? Which class? Who is in J5? Okay, I'll post the information on Google Classroom. Right. So when you check there on the last column, we have got helium at the top. That's 2 electrons. So let me check the volume here, but otherwise we are going to end very soon. Now, so we are saying, since we are having helium in the last column or in the last group, it has got maximum of 2. Then let's move down onto period number 2. Let's check. Right, if you check on the next element below helium, we have got what? It has got an atomic number of, what's the atomic number? It's 10, right? Now, this is now the second shell. So we have said already that the innermost shell has got a maximum of 2. So that one, neon, is having what now? It's having 10 electrons, right? So remember, the innermost has got 2. So how many electrons are left? 8. Are we clear there? And neon is having how many shells? 2. So it means then that since it has got 2 shells, the innermost has got 2, and the outermost one will have what? Maximum of 8. That's how we come up with the maximum number of electrons in a what? Each shell. So the first row tells us that the maximum is 2. Then the second shell in period 2, it has got a total of 10 electrons. So the maximum number of electrons in the second shell becomes what? 8. Then if you check on the third one, what is the maximum number of electrons in the outermost shell? It has got 18 electrons. So how many are in the outermost shell? Okay, just look at the period that we are in. Subtract the number of electrons in the previous period, right? So it's just like you can just then say 18 minus 10. So that's the maximum number of shells in the outermost shell of what? Of that element. So the first shell is maximum of 2. The second one, maximum what? 8. The third one is maximum of 8 as well. That's how we come to know the number of elements in the last or outermost shell. Then I think we'll continue from there, boys and girls. I can see others are going out.